Okay, welcome back, Year 11s. We're looking at, what are we looking at? Question 3, 7b, question 3, it's down here. Why is 0.527 a rational number? Oh, sorry, I've lost my pen. Here it is. 0.527, because you can express it as a fraction. It goes down to the thousandths. 527 thousandths. Right, we've got tenths, hundredths, thousandths, 10 thousandths, 100, etc., etc. Okay, next one. Why is 0.999999999? They're saying it's rational, so we can express it as a fraction. In fact, they're saying it belongs to the set of integers. Well, what integer? Well, they're saying it equals 1. Give evidence. This is the evidence. 0.9999 is 9 ninths, and 9 ninths just equals 1. If you're familiar with your ninths, 1 ninth, 0.1111 recurring. 2 ninths, 0.2222 recurring, right? So by the time we get up to 9 ninths, we've got our 0.9999999. Well, okay. 9 ninths equals 1. Easy peasy. All right. Next. Question 4. It's over the page. Here it is. Prove that the sum of two even numbers is even. The sum, and then we've got to prove the sum of two odd numbers is even. Okay. Now to do this, we need a little formula for even numbers and odd numbers. Right, so the sum of even numbers, and I'm going to say even numbers can be expressed, an even number can be expressed by this formula, 2n, where n is an integer, belongs to the set of integers, right? Although n could not be 0 in this case, can't be 0. Okay, and then I need to sum two of them. I think we'll make the second one a consecutive even number. So if we imagine that the n values were the same value in this equation, we wouldn't want to sum the number with itself. So I'm going to go for, there's an even number, not sure what n is. That n's the same. So that's the same number plus 2. It'll be two even consecutive numbers. And if I sum them up, I would get 4n plus 2. Now I need to show that this is always even. Always even. Is it? Yes, because anytime you times a number by 4, so all multiples of 4 plus a 2 are even. All right, so that's as much as we really need to do here. Let's think about summing odd numbers. Sum of odd numbers. So normally I write odd numbers like this. I write 2n minus 1. 2n minus 1. You might need to stop. Is it possible to ever get a 0 from that formula, given that n is an integer? N belongs to the set of integers, because we don't want to think about 0 as being odd or even. But you'll find that you can't get a 0. It's like, if I put the number 1 in here, I'd have 2 minus 1 equals 1. If I put the number 0 in here, I'd have 0 minus 1 is minus 1. So that's okay, right? So I don't need to write n is not equal to 0. I can just leave that statement as it is. Let's sum. We need to now sum my first odd number with another one. Well, what would be the next one? The next odd number up would be 2n plus 1. I mean, I could have done 2n plus 3. You know, it wouldn't really matter. Oh, I didn't mean to do that, sorry. I just meant to erase this. Right, so I didn't mean to erase that. Okay, so we just want two even numbers to add together. So what do we get here? We get 2n plus 2n. That's 4n. Then we get minus 1 plus 1 is 0. So it's just 4n. And that's good enough, right? So we then say all multiples of 4 are even. Therefore, the sum of two odd numbers is even. Okay? All right, back to the question. Question 4. We're here at C, 4C. The difference between two rational numbers is rational. Okay, a rational number, how could I come up with an expression for this or a little formula for it? A rational number is any number that I can write as a fraction. For some reason they normally go to P's and Q's. And I've forgotten already, are we looking at a sum? No, the difference. The difference between two rational numbers is rational. All right. So let's minus away from this rational number on S. How could we do that? We need a common denominator. Okay. QS. Right. Now, how did we get that denominator? We had to do Q times S. This fraction already had the Q, but it needs to be times by S. So we'd have SP or PS minus. What about over here? We timesed that denominator by Q. So we have to times the top by Q. So we have QR. And this is still rational. It's still a fraction. And that's really all we need to do. Okay? And the last one, the product of two rational numbers is rational. So if I took these two rational numbers, P on Q, but this time we multiply, R on S, we're going to end up with a fraction that we could express from those numbers, whatever these numbers are, it doesn't matter. We're just going to get another fraction expressed from those numbers, and so therefore, because it's still a fraction, this is still rational. So don't overthink those proofs too much. What we've just done there is satisfactory. Okay.